Good day, everyone. This is Orekoya Olusegun, Physics Mathematics Fundamental on YouTube. Please, before we go into today's topic, do not forget to like, share, subscribe, and click on the notification button to have more of my video. Thank you for your patronage. I quite appreciate your interest. Today, we are taking a topic in mathematics, and that topic is on arithmetic and algebra. Many students will have been wondering, what is algebra all about? What is arithmetic all about? What is the relationship between algebra and arithmetic? What I just want us to let us realize is this: when we are dealing with a known quantity, known quantity, we are dealing with what is called arithmetic. When we are dealing with unknown quantities, we are dealing with what is called the algebra. Like for instance, if I write 5 plus 7, we know what 5 represents and we know what 7 represents. 5 represents, let's say, 5 objects. 7 represents 7 objects. When we now add 5 objects to 7 objects, we are going to have 12 objects. But in this case here, if I say x plus y and I write z, we do not know the number x represents. We do not know what y represents. We don't know what z represents. So this kind of expression is in the realm of algebra. Now we can have combination of numbers and letters also in algebra. Like I can have x minus 7 is equal to, let me say, 8. This is arithmetic, this is algebra. So now we are having an unknown here. This is a form of algebra. Or we can have x minus 7 is equal to y. We are having two algebraic quantity here together with arithmetic quantity. Since we are having unknown also here, this is a form of algebra. By now, I believe that you must have understood the difference between arithmetic and algebra. Now, let us consider elements of algebra. When I have something like 3x and I have something like 8x, now the number I have in front of this letter is called coefficient. It's called coefficient. This number that I have in front is called coefficient. If I have ordinary x in mathematics, the coefficient is assumed to be 1. So this x is actually means 1x. So the coefficient in this case is 1. That's our coefficient. Now here, the number in front here is 8. So the coefficient is 8. And these letters that is written beside the coefficient is the variable. Now, because this variable is the same thing as this variable, we say okay, or variable term. You can call it variable term. So this variable term, which is x, is the same as this variable term, which is x. So we say 3x and 8x are like terms. So like terms can be added, can be subtracted, can be divided, can be multiplied to each other, with each other. Now, that is another example is this. Let me say I have 3xy, then I have 8x. Now, in this case now, our coefficient is C3. The coefficient is T3. Coefficient, I'm shortening it, is C3. The coefficient here is also still 8. But the term here, the term I have here is xy. The term I have here, the term that I have here is just x. So this particular term xy and x, they are called similar terms. So this xy and this x I have here are called similar similar terms. So, like for instance, let's say I have 3x. Let's say I have 3x y minus 8x. Like I said, this is a term xy and this is another term x. So in that case now, we can factorize what is common in this similar term. What is common here is x. So if you take x out, you'll be left with 3y. If you take x out here, you'll be left with 8. So similar terms can be factorized. Similar terms can be factorized. Also, like terms can also be factorized. Like for instance, these like terms. Let's say I have 8xy and then let's say 12xy. Let me say I have the combination of these two. 8xy, let's say, plus 12xy. Now, you can see that this term that I have here is the same as this term that I have here. So these terms are called like terms. They are called like terms. And the coefficient I have here is 8. The coefficient I have here is 12. So these like terms too can be factorized. What is present in common is xy. So I can put xy out. What I have left will be 8 plus 12. And 8 plus 12 gives us 20. So the total thing will be 20 times xy, which is 20xy. So this shows to us that like terms can be added together. You can just say 8 plus 12. That's 20xy. So like terms can be factorized. Similar terms can be factorized. Like terms can be added together. But similar terms cannot be added together because they don't have the same variable. Like for instance, look at this. Let's say I have 7pq and I have 8p. If I write 7pq plus 8p, I cannot add them together because this 8p doesn't have q. The only thing I can do for these similar terms, we call it similar terms. This term, which is pq, this is a term, and this p is another term. So because they are not exactly the same, we call them similar terms. Similar terms. So the only thing we can do with similar terms is to factorize what is common in them. What is common here will be p. So if I put p out, I'm left with 7q. Then plus, if I take p out, I'm left with 8. That's what I can do concerning similar terms. Now, let's consider like terms. 7pq plus 8pq. pq here is a term. And this pq here is also a term. They are like identical twins. So, because they are identical, they can be added, they can be factorized. Now, if I want to factorize, what is common here is pq. So, I can factorize pq out. pq, I can factorize it out. I'm left with 7 plus 8. 7 plus 8 gives me 15. 15 times pq will give us 15 pq. Then I can just add them straight because they are like terms. These two are called like terms. They are like terms. Because the variable we have there are the same. So like terms can be added. I can just say 7 plus 8, that's 15. Then I pick one of these variable, pq. So I have my answer concerning like terms. Then I have my answer concerning similar terms. I believe that you can differentiate between what is called like terms and similar terms. Thank you for having you. Have a nice day. Please do not forget to share, like, subscribe. Click on the notification button to have more of my video. Have a nice day. Bye.